In this topology, I have 5 switches, switch 1, 2, 3, 4, and 5. Nothing has been configured on these switches except for the switch names, so they are running a default configuration. I've connected hubs to the switches so that we can do Wireshark captures in this topology, but please note this is not a recommended spanning tree topology. It's simply used to demonstrate some of the features and functions of spanning tree. So let's determine who the root switch is. On switch 1, show spanning tree. Is this switch the root of the spanning tree? The answer is no. We can see that this switch has a MAC address of the following, but the root has a MAC address of the following. The local switch also has a path cost to get to the root switch via port 1, which is gigabit 00. In other words, its cost to get to the root bridge is 4, based on the IEEE 1998 specification. Scrolling down, we can see that gigabit 00 is the root port for the switch. So in other words, because the path cost is 4, it's most likely that switch 2 is the root switch. Because this port has a cost of 4, and the path cost to get to the root switch is 4. In other words, there'll be a single link to get to the root bridge. On switch 2, show spanning tree. This switch is the root, and we can see it displayed clearly in this output. You can also see that the MAC address of the root and the local bridge or local switch is the same. What you'll also notice is that all ports are forwarding. So this is the root switch currently. Let's see what BPDUs are being advertised by that switch. So here's a BPDU. The destination of the frame is the well-known MAC address for spanning tree. In the spanning tree output, we can see that the switch is running rapid spanning tree. We'll change that in a moment. But notice the path cost is 0. That's the root identifier and the local bridge identifier of the switch, and the values are set the same. Other information, including the max age, hello time, and forward delay, are shown in the output. So I'll stop at that Wireshark capture. So switch 2 is currently advertising that it's the root of the topology. Let's have a look at what switch 3 shows with regards to path cost. Show spanning tree. It also has a path cost of 4, and it's using port 1, in other words gigabit 00, as its root port. So this port is the root port to get to the root of the spanning tree, and this is the link the switch is using with a path cost of 4. What about switch 4? Show spanning tree. We can see here that the path cost is 8, not 4, and the port that it's using is gigabit 00. So in other words, this port is the port that it's using to get to the root bridge. It has a path cost of 4 because this link has a cost of 4 and this link has a cost of 4. On switch 3, we could use the command show interface spanning tree interface gigabit 03 cost to see that it's advertising a cost of 4 on this port. So from its point of view, it's got a cost of 4 plus 4 to get to the root bridge. We can also use the command show spanning tree root to see that the local switch is using gigabit 00 as its root port. The cost to get to the root is 8. The root ID or bridge ID is the following. So 4 plus 4 gives us 8. What about switch 5? So switch 5 shows spanning tree. There's the command. The output shows us that the path cost to the root is 12. In other words, 4 plus 4 plus 4 is 12. So as you can see, the path cost is incrementing on a per link basis. Once again, show spanning tree root. Path cost to get to the root is 12. The local root port is gigabit 00. That port has a port cost of 4. Because the switches are using the 1998 IEEE cost, a 1 gigabit per second port has a path cost of 4 by default. So let's make some changes. We'll make switch 1 the root, see how that affects the BPDUs advertised by switch 2, and we'll change the path cost method to long to see how that affects the path costs of the switches.